Greetings once again, AP Calculus BC students. Mr. Record here from Avon High School. And we're going to talk about, in our final video over topic 615, the idea of a trigonometric integral that's going to require a very special identity that might not be real clear to you. It's not a really commonly encountered identity. Once again, topic 615 is an additional topic that I've put into my curriculum that is not going to feature problems that are tested on the BC Calculus exam. However, it's very common that these problems can be encountered in a typical college Calculus 2 course. So we definitely welcome those of you that are watching the video that are coming from a college level Calc 2. So let's take a look at the problem that I'm talking about. So if we go right down here to the example 9, we're going to take the integration, the antiderivative of sine of 5x times the cosine of 4x. Now, what makes this problem challenging is because you have two different arguments within your trig functions. One's a 5x, the other one's a 4x. And that creates a little bit added level of difficulty. If they were both the same, we could pull off a simple u substitution and be on our way. Now, the way that this problem is presented, there's actually a couple of different ways that you can solve it. I want to talk about the easy method first. And that would be to implement one of these three sine, cosine products with different angles formulas, or often they're called the product to sum identities. Because you can see that we start with a product, and then over on this side, we have a sum. Well, or a difference, but a difference is really the sum of something that's negative. And so that's how we break these apart. Now, there is a drawback of using the identity method. And that drawback is the fact that you're going to have to memorize these three trig identities. All right? And so you'd have to realize that the sine and cosine combination is actually going to be this middle identity, right? And the middle identity has a pair of signs in it, right? When I was a student, I always memorized these where if I had two different trig functions, I knew that I had sine and sine. So different means both are sine. If they're the same function, sine, sine, and cosine, cosine, then I knew that we were cosines for both of our parts. And then I would just try to memorize which one was negative, and I remembered the structure of the other, 6 pieces here. Always m minus n to start and m plus n over here, and I was pretty much in good shape. So let's take a look here and see what we would rewrite this as. We would start with our 1/2. That's a very common thing that students tend to forget. And then we have the sine of m minus n. Well, in this problem, it should be apparent that the m is 5, and really the n is 4. Now, they both have x's, so that just means we subtract the 5 and the 4 and get 1, and there's still going to be an x value. And that takes care of the first term. Then we will add, and of course we have sine, and then the formula says that we're going to add our m and n and get 9x. And then that pretty much closes it out so that we can integrate it. And yes, we can indeed integrate this thing fairly easily. We can bring out this 1/2, and then we could integrate the sine of x, which is negative cosine of x. And then when we take the antiderivative of sine of 9x, now remember this is a little u substitution, right? We're thinking that the u is going to take the form of 9x. And therefore his derivative would be 9 with respect to x, and that means that you're going to have to offset with a 1/9, right? We're going to see that this dx is equal to du over 9, which manifests itself in a 1/9. And then the integration of sine is negative cosine, and we'll keep that 9x there. And then that is all that we have to do. That is our answer. And so it doesn't really require a whole lot of heavy lifting once you know the trig identity. Now, let's suppose you run into a problem like this, and for the life of you, you can't remember these trig identities to save your life. Well, fear not, because you have another option. Now, I'm not going to walk through this option from start to finish, but I am going to at least get the ball rolling here for you. But if you think back to a previous integration technique that we talked about, I believe it was topic 6.11 in the College Board course and exam description, integration by parts. And that's exactly what's going on here. You have two separate entities right here, a sine 5x and a cosine 4x, that are being multiplied together. And that's a tailor-made integration by parts problem. If you follow my acronym that I used, LIATE, you'll find that we're in a tie for T, trig, right? Both of the components contain trig expressions. So that means that you can just choose whichever one you want to be your u and whichever one you want to be your dv. Don't worry about it. So let's let the sine of 5x be our u, let's say, and we'll let the dv be the cosine of 4x dx. Go about your normal process of taking the derivative of your u, which would be 5 cosine 5x dx. Take the antiderivative of your dv, which would be 1/4. See, that's where it can be a little tricky, right? We're going to have to reciprocate that 4. And we have sine of 4x. And then you'll structure your formula, and I'm just going to write the actual formula, u times v minus the integral of v du. Okay? What you're going to notice is that you will have a v du here that's going to require another iteration of integration by parts. So you'll have to set up another u and dv. All right, I will warn you that if you do that setup, pay very close attention to what coefficient of x that you used for the u in the first setup, because you'll have to stick with that same coefficient. You're going to find out that it's a cosine of 5x. I think you can see it right here as part of your v du. Go through the process of that second integration by parts, and then what's going to happen is that you're going to have that very typical add over step. What do I mean by that? Is in the process of reconciling the second integration by parts, you will have an integral with some coefficient that I'm just going to use a hashtag for the number, and there will be, I promise, a sine of 5x, cosine of 4x within that. It's going to happen as long as everything is done correctly up to that point. Now, I can't tell you if it's going to have a plus or a minus sign there because I don't really know. I can't look that far ahead with this setup. But whatever sign that is, you'll just perform the opposite operation to move that integral over to the left, join the original integral that was already there, and then you would divide that new coefficient back over to the right side to get your answer. And if you go back to some of our later examples with topic 611, you'll see problems that were handled like this. Now, I want to warn you that the answer that you get is drastically different from this one. It doesn't even look like it's in the same ballpark as this one. But I do promise you that it is accurate. They are the same, and I would encourage you to use technology to perhaps graph both of those equations and see both of those expressions as functions of y, or equal to y rather, and see if they generate either the same graph or perhaps a vertical shift. All right? Because of this problem, teachers, this might be a message more geared towards you. If you were to ask questions like this on an assessment, I would steer clear of making these multiple choice, because then you sort of will pigeonhole your students into having to use one method or the other. So these will much better work as open response questions, which is what my students are going to see, and then I'll let you do it either way and score the points accordingly. So there you go. Hopefully that makes some sense. This does put an end to our topic 615, and we hope that these videos have been very helpful. And of course, we have some videos rolling in from topic 616 that cover trigonometric substitution. So until next time, keep studying calculus, and we'll see you.